Welcome to Phyla Software. I'm Petros Savidis, and in this video I'm going to show you how I designed my test suite using caching. To illustrate in this example how you can design your test suite in a way that allows for performance improvements, we're going to use the electricity bills application I've made for myself that takes electricity bills and uploads them into a Google Sheets API. So without further ado, let me open the design of the app and show you how the application looks like. Long story short, it takes a electricity bill PDF, creates a new execution, and internally it uses the heart of the software, which is a bill parser that converts the PDF into the model, and then the model is in the end stored in a Google Sheets API for real executions, and the test suite is actually using a data store that is in memory in order to avoid calling the Google Sheets API all the time. What is interesting about this design is the heart of the software, which is the bill parser, which is the core domain logic of the application. And that's why we also wanted to test it separately. Let's see the test suite, how it looks like, and how I designed it to be able to reuse data and improve performance. So we have multiple tests, unit tests, that are using a test resources class, which internally is using a cache. These cache can be populated by two methods, which are the main public methods that the tests can access. Get them as resources, as files with the get resources file method, or get them as parsed models with the get test bill method. Whichever of these two methods is called, it populates a cache with resource holder entries, which can hold files or electricity bills, depending on what operation has been already completed. If a test wants a resource, then this resource is going to be placed in the cache in the respective resource holder entry. And if another test wants a model for the same document, then that model is going to be placed in the same resource holder for that entry. That way we guarantee that the data will be reused and accessible by any test. Notice how this design is allowing for mutable values to be populated under the same entry in the cache. These resource holders will be accessed in a thread-safe way. If a model cache is updated, then it's locked so that no other thread can touch that entry while the update is occurring. Now, let's see how this looks like in the code and what kind of benefits this brings us as performance improvement with this design. So under test resources, we have a test bills folder which has different PDF bills from different months. And these test bills are used as test data for our application and can be reused by the tests. These are made publicly available by the test resources class, which essentially has a public API which allows you to fetch an electricity bill by its file name, or you can get a resources file using the file name. Any of these two executions is going to end up in a population of the cache with that respective entry. So we are holding in a concurrent hash map entries with the file name and the cache and the resource holder, which is the DTO, which is holding the file and the respective model for that document. Notice this method, this interesting method here called asBill. If a test is calling this method, then it's going to lock this entry and calculate the model and populate that resource holder entry so that the next time it's asked, the bill is going to be present and not null, and it's going to be fetched. This essentially is the double check blocking pattern that we apply here to update the value. As an example to illustrate the performance benefits, let's just turn off this method here and allow all the entries to be calculated again and again. So let's see how our application is performing without using any cache. All right, now this is going to be called every time, and let's run the application. Okay, so we have 85 tests, and in total it took 1 second and 272 milliseconds. Let's run it again a couple of times just to have multiple samples. Okay, yeah, it takes roughly 1.2 seconds to complete. You might argue that this is not a lot, but in a production system which uses many files and many tests, you can understand that this can easily pile up. Now, from 1.2 seconds, let's see how the cache is improving our performance. So if we run again the test, we see we have 85 tests in 710 milliseconds. So we have a difference of 500 milliseconds approximately. So today we saw an example of a simple application that we defined a dataset that can be reused in the future by other tests. We defined the data access patterns that our application is going to use in our test suite. You can design your test suite in a way that is extensible in the future. And of course, a small reminder, when you're caching, you're trading off performance gains with space. In our application, we are caching files and parse models in a hash map, in a concurrent hash map. So that's a conscious decision that you're making as a designer when you're early on planning ahead how exactly is the shape of your test suite going to look like. If you found this video helpful, please like and subscribe, and I'll see you in the next one.